In this video, I'm going to talk about capacitors. So before going to the capacitor, every element is divided into two categories. The elements we know: capacitor, inductor, resistor, and voltage source, current source. Those are the elements. So there are two types of elements. One is an active element, another one is passive element. So when it comes to the active element, an element that capable of delivering average power which is greater than 0. So basically, which delivers energy, we call it as active element. Examples are voltage source and current source. Now, the passive elements are the elements which cannot deliver energy on their own without support of any external source. Those are called passive elements. Resistor, inductor, capacitor, these are called passive elements. Now, I'm going to talk about capacitor in this video. Capacitor is an electrical device. It's nothing but two conducting plates. Okay, I'm drawing a straight line, but when you look into the three-dimension picture, that's just a plate. Okay, mostly round plate or square plate, rectangular plate, anything. Two conducting plates separated by a dielectric material. So most of the cases, this dielectric material could be a paper or air. Those are all the dielectric materials. Now, capacitance we indicate with C, measured in farad. Here in this picture, you can see different types of capacitors. Most of the time, capacitors are going to be either in microfarad, picofarad, and nanofarad, something like that. So see this one, this big blue one is 4700 microfarad, which is 4.7 millifarad. I don't see, so this black one, I don't see, it's look like 170 microfarad, 0.7 microfarad, here 22 microfarad. So these are all different types of capacitors. Here you see the small capacitors, most probably use them in the electronic components. I see all of them. These are the electronic capacitors are used in electronic circuits. When it comes to the electrical motors, the capacitor size is a little bit bigger. So capacitance we indicate with C, measured in farad. Okay, capacitor symbol is C, measured in farad. So do not confuse with capacitor with the battery. Capacitor, this is the symbol. Battery, we always have positive plate as a longer plate, negative plate is a smaller plate. So can I replace a capacitor with a battery? Because capacitor also stores energy. I didn't talk about it. So the main advantage of capacitor is it stores energy in the form of electric field. Capacitor stores energy in the form of electric field. So now here battery also stores energy, right? So can I replace a battery with a capacitor? No. The reason behind it is capacitor discharges all its energy in quick moment, but whereas battery is a controlled, it disperses its energy in a controlled way. So like if you connect a battery to a flashlight or torchlight, so for the flashlight, based on the bulb resistance, it may supply energy for 2 hours, 3 hours, depending upon the resistance of that bulb. But capacitor doesn't matter about the resistance. It supply all of its energy in a quick second. That's the difference between capacitor and battery. So do not replace a battery with a capacitor or vice versa. Now, the energy stored in the capacitor is half CV squared, where C is the capacitance value, V is the voltage. Okay, voltage across the capacitor. Now, the current passing through the capacitor, I equal to C times dV by dt. So if you have a capacitor, usually each capacitor has two plates. One plate is positively charged, another plate is negatively charged. The amount of the charge is same on both plates, but one is negative charge, another one is positive charge. Okay, so the current passing through this, I equal to C times dV by dt. or voltage across capacitor is 1 over C integral of I dt. Now, the value of capacitance C equal to K times epsilon naught A over D, where K is the called dielectric constant. It varies from material to material. So basically, what kind of material we are using in between these two plates. Okay, it varies 1, 2, 5, 10, something like that. For air, K value is 1, air and vacuum. But for every other material, K value changes. Epsilon naught A is called permittivity of free space. Epsilon naught A is permittivity of free space. That value is 8.85 times 10 to the power of minus 12. Okay, and A is cross-sectional area, D is distance between the plates. So A, most of the cases, A is large compared to the distance between the plates. Now, one more important point about a capacitor. So if you look at resistor, we already know resistor. So here is 10 ohm, here is 100 ohm. What is the advantage of resistor? It opposes the rate of it opposes the flow of current, right? So in 100 ohm oppose more compared to the 10 ohm. Same way, when it comes to the capacitor, the more numerical value indicates the less value of capacitance. I mean, it stores less energy based on the supply voltage. That's one way to look at it. Another way is the main advantage of capacitor is it opposes rate of change of voltage. So capacitor opposes the rate of change of voltage. That is the main another advantage of capacitor. I mean, it stores energy, we know that. And the second one is capacitor opposes the rate of change of voltage. That means it is impossible to change the voltage across capacitor in 0 time. Okay, so it needs some little time. So small numerical value indicates more opposition for the rate of change of voltage. So it's just opposite to the resistors. Okay, and at the same time, as I said, capacitor stores energy in the form of electric field, and here you have charge on each plate. To find out the charge value, Q equal to C times V, where C is the capacitance value. Okay, Q is the charge in coulombs, charge on each plate. C is the capacitance value in farad. V is the voltage between the plates in volt. So what is the voltage between these two plates? Hypothetically, I'm just taking 10 volt, and if I know the C value, I can tell you what is the charge on each plate. Okay, I'll stop this video here. In the next video, I'll continue with the series combination of capacitors and parallel combination of capacitors. Thank you.